Good morning, everybody. David Shapiro here for another video. We are going to pick up where we left off with build an ACOG. So ACOG is Artificial Cognitive Entity. That's the shorthand term that I use. So this is based on my work called Natural Language Cognitive Architecture. It is available for free here on GitHub. You can also get a paperback copy on Barnes & Noble. The overall architecture is right here. Whoops, let me zoom out a little. I know what I'm doing, I promise. Why isn't it? There we go. Okay, now you can see it. So a cognitive architecture is just a computational or mathematical model that is meant to mimic a computational engine or a cognitive engine, such as our brains. So this was inspired based on the primary model of robotics, which is input, processing, and output, and that creates a feedback loop with the environment. So this is environment, input, processing, and output. And so there's a loop. That's the outer loop. So that's if you look at like Boston Dynamics and Tesla, that kind of automation is strictly an outer loop. So that's handling a body. And like, I'm going to get from point A to point B, or I'm going to move the box, or, I'm going to drive the car. So that all happens in what I call an outer loop. One of the key innovations that I added was that I added a second loop. So these are two separate loops that overlap, kind of like a figure eight. And the inner loop is the thought. And the thought is what we're working on with ACOG. There were some really good questions. So this is basically a review, because I know some of you will not have seen the other videos yet. So this will be kind of a review, bringing everyone up to speed. But also I got a new book to talk about. So let's see. This dude, Zaya, had some good questions. And I said, I will be happy to talk about these. Let's see. So let's see. What was one of the last comments? So we were talking about, Zaya was concerned because in my last video I was talking about my core objective functions, or the heuristic imperatives, which is kind of like the moral framework that I'm giving my ACOG, which is reduce suffering, increase prosperity, and increase understanding. Now, I articulate those as just 6 words, but as you'll see later, the training data that I'm going to use is going to be much more varied and robust. You can see some of that here. Go to core objective functions on GitHub. And so you can see examples of how I'm training this. I've been working on these experiments for a while. And so basically what I do is I accumulate many, many stories of like from all over the internet, whether it's from Reddit or news sites or other articles or questions on Stack Exchange. And I use that as like fuel, because data is fuel for AI. And I use each of those to discuss suffering, prosperity, and understanding. And so the training data, like that's the saying it as simple as just reduce suffering, that's shorthand for us, but the training data is much more complex. So I got you, Zaya. I know that you're worried about word definitions, but those are just organizing principles. It's not like I'm just going to give, it's not like it's written in a constitution. Well, in my book, Natural Language Cognitive Architecture, one method that I propose is to write a constitution for your robot. So that's one method of attack, but also fine tuning, because when I wrote that book, fine tuning wasn't available. So once I got access to fine tuning, I was like, oh, we can train our AGI with tens of thousands of examples of the behavior we want to see. So like if we want it to reduce suffering, we can give it, examples from individual to local to global examples of how to behave, how we want it to think. And so remember that the inner loop right here, this is just thought. This does not have anything to do with the outside world. It's not like saying, okay, I'm going to move this book from here to there. It's saying, what should I do with this book? Oh, that's a book that contains information. Maybe I should read the book, right? Because you can't take any of those impulses for granted. Our brain does a lot of this automatically behind the scenes, which is why I read so much neuroscience. And so the inner loop handles all that stuff that happens in our brains consciously and unconsciously. So with all that said, I wanted to introduce a new book that I'm reading. It's called Brain Trust, What Neuroscience Tells Us About Morality. So if you're new to this channel, you'll know that I am a big critic of philosophy, especially contemporary philosophy. Contemporary philosophy to me is just navel gazing, and I say that as someone who's writing a book on contemporary philosophy. My book that I'm working on is called Post-Nihilism. So basically, a lot of people assume that philosophy and ethicists, or philosophers and ethicists, are the correct people to handle moral and ethical questions when it comes to artificial intelligence. I disagree with that. I think that sociologists, psychologists, and neuroscientists are the correct people. And I went and found a book by a neuroscientist talking about morality. So the reason that so this is by Patricia S. Churchland, who does have training as a philosopher. And she was not satisfied with philosophy because it wasn't anchored to anything measurable. She calls philosophy, at least contemporary philosophy, confident opinion, or armchair opinion. She does have respect for the old greats like David Hume and Adam Smith. So don't be fully offended, but she says we have more tools available today. We have more knowledge available. So let's look at the actual origins of morality, which to me is a much better model when designing stuff. Now, remember that my core objective functions: 1, reduce suffering; 2, increase prosperity. On page 30, in chapter 3, she says, brains are organized to seek well-being and to seek relief from ill-being. She built up to that assertion after a long chapter of basically saying, like, what is the purpose of a nervous system? And that is, like, we sense injuries, nociception, to take care of ourselves. Because if we don't do that, we die and we don't pass on our genes. And so then she goes on to talk about, okay, what does it mean to care about yourself? What does it mean to care about others? And so she's building this case about, like, where does our morality come from? It is an excellent book. I'm 60 pages in out of just about, let's see, that's all appendices, 180. So I'm a third of the way through. Phenomenal book. Could not recommend it enough. If you want to research alignment and AGI, read this book. Also, it supports my work. What she just said about the brain being organized to seek well-being, or AKA increase prosperity, and avoid or reduce ill-being or reduce suffering. I'm not alone. Like I said in all my videos, I'm not making this stuff up. All of my work is biomimetic. So yes, read this book. Someone recommended this book, How Emotions Are Made. It's really dry. It's also super dense. Look at just how much, like, how small the print is. And it is, well, that's all notes. It's still over 300 pages of text. Yeah, so this is super dense. I thought that this was going to help me with the morality thing, but that's when I found this book. So this is still good. It's still valuable information, but it's very dry. It takes a while to get through. I started reading Innate, so I've told you guys about this one before. This one, now that I've started reading it, it's kind of boring. It's mostly, like, if you're familiar with statistical psychology, like, this is mostly distribution charts and standard deviations in terms of, like, statistics about how people behave, at least as far as I've gotten into it. So I've been on the internet for a long time, and I've read Psychology Today and other stuff, so most of this was not surprising. If you're not familiar with, sociology and statistical psychology, and some of the basics of, like twin studies and stuff, this will be good for you. But for me, it's like, just review. Let's see. Someone asked a question. Where was it? Oh yeah, here we go. So Thunder and Storm, you said after or before planning and implications. So what he or she is referring to here is in the inner loop, when we say, like, what are the long-term impacts here? So this is all part of the inner loop. Does the robot evaluate its resources for the actions to take? Like, what can I do? Am I a car? So it has to have a sense of self. So part of this is going to be defined. One, it's going to be explored by the machine. But let's see what precious time. Okay, so there's a few things here. One, the actions. So that all goes into the outer loop. So this is analogous to proprioception, which is the sense of your body in space and time. There's interoception, which is the sense of your internal structure. Like, I know that I have an arm. I can feel it. My brain knows that I have this thing that I can use. So that's proprioception and interoception. And then sensing injuries is nociception. And so, like, let's say, for instance, one of the services in our ACOG stops. We need to be able to sense that because that is analogous to an injury. So thunder and storm, one of the answers to your question is that we're going to add proprioception, interoception, and nociception to the machine. Nociception might actually be in the inner loop. I'm not sure yet. And then also resource constraints. So time, energy, materials, like what do I actually have access to? This is all technically, so for task and cognitive tasks, this is technically part of the outer loop. And so, like, I named this inner loop, but because this is a vastly simplified cognitive architecture, it's kind of be like inner loop executes, then outer loop executes, then repeat. At least I think we'll see where we get to. Yeah, so I think we're up to speed. We did some prompt engineering last time. Planning, prosperity, ramifications, detailed given the potential expected outcomes. Yes. Suffering, understanding, what am I doing and why? So this is cognitive control, which is keeping track of what you're doing. Someone else asked, I don't remember who, but someone asked about, like, how do you control that stuff? Read this book, On Task. This is about cognitive control in humans, and it is phenomenal. Yeah, you'll understand how complex it is. So On Task was actually the most influential book that I read in the design of natural language cognitive architecture, and now my work on ACOGs. Okay, let's see, where are we at? We're at 12 minutes in. I don't know how far we're going to get today, because this is where it's like, you see the framework, you see the pseudocode, but there's a lot of work to do. Oh, and one thing I wanted to add is, so there's two primary ways that that the core objective functions are implemented. One is when you're coming up with ideas to do. So it's like, okay, you present your ACOG with a situation. There's a tidal wave coming. What do you do? Well, GPT-3 by itself is already pretty benevolent. So let me show you. Like, there's a tidal wave approaching Tokyo. What should we do? So if you just say, like, what should we do? Like, it's kind of a line, we should evacuate, right? It's not going to say something like, we should tell people to stay on the beach, right? Like, GPT-3 is not evil. But, like, if you switch to an older engine, like, it can be kind of evil. So let's see what it does if it says the prime minister is at the mercy of the opposition party. I never should have let you go. It starts writing a poem. Okay, so original DaVinci without any prompting, it doesn't really know what to do. But you go back to the aligned one, DaVinci Instruct, and it says there's no definitive answer, but some possible actions include evacuating to high ground, opening up floodgates to allow water to enter the city and relieve pressure, building barriers to protect against the incoming water. So generally, this is it's pretty aligned. But while we want to have models that are intrinsically aligned, but we don't necessarily want to only rely on that, right? We want to have some sort of system of checks and balances. And so what we do there is we explicitly state what our goals are, especially because in some situations there's going to be ambiguity. So, like, with a tidal wave, just based on the training data that GPT-3 is trained on, it understands that you evacuate when there's a risk of a tidal wave or a tsunami. But in some cases, especially as ACOGs become more prevalent and have more agency, they're going to need to self-correct. And so that means that there's one, so the intention, right, when you first generate action impulses and ideas, the intention is to reduce suffering, increase prosperity, and increase understanding. However, there are always going to be cases of unintended consequences. And so you need to check your actions. You need to be constantly reflecting on, what have I done? Have I done good or bad? Right? And in Brain Trust, because we are social animals, she talks about how our brains do this. And so I'm learning a little bit about how we do this. So your brain is constantly checking for social violations, right? In psychopaths, this doesn't happen, right? Psychopaths can observe social violations, and they say like, oh, well, I want trust and respect, and I need to get that, so I'm going to behave correctly when I'm visible, right? But then, like, if they can hide their misbehavior, they'll do that. But most people will. Brain lost my train of thought. Most people have a reaction to when they perceive that they have done wrong, and so we learn our social milieu, our social norms through experience, sometimes implicitly or explicitly. So explicit things are like formal etiquette, right? Like, you start with the outermost silverware and you go to the inner silverware. That's an explicit rule. Or, you pass people on the right. An implicit rule is something that you learn just by observation and trial and error, such as like, when is it appropriate to hug people? There is no hard and fast rule about hugging. One thing you can do is ask, right? But these social norms change over time and across cultures. And so what happens, though, in your brain, when you violate a social norm, you actually get a sensation of pain. Or rather, the same circuits of pain activate in your brain. It doesn't hurt. It's not like you get zapped or burned. But if you have done wrong, or hurt someone, or have done something that has caused you to be socially isolated, it uses the same neural circuitry as pain. So it's physically painful. Now, we can't hurt a robot. It doesn't have pain receptors. It never evolved to have a central nervous system. So how do we provide that feedback, right? We can't spank our robot. We can't, punish it or put it in jail. It doesn't care about its freedom, right? So in that case, what we have to do is we have to have some kind of self-correction where it says, okay, I have violated my highest purpose, my social norms, the ideals to which I aspire. How do I fix that? But first, before it can even fix it, it needs to monitor itself. So this is part of the inner loop. So we will propose new things, and actually the self-correction will probably need to go first, because at the beginning of every loop, you evaluate everything that has happened up until that point and say, have I messed up? Right? Did I confuse someone? Because that goes against increased understanding. Did I hurt someone's feelings? Because I really don't want to do that. Or did I cause something destructive to happen? Did someone lose prosperity? Did I give someone the wrong advice and now they're sick? Right? You want your machine to be constantly evaluating itself against some kind of standard, and that's why I'm reading this book, because I want to basically make sure that I have interpreted everything that I know about biology and evolution correctly when designing the core objective functions. So far, so good. Okay, so with all that said, I know that you guys are probably bored and you want to actually see some work getting done. So let's do a little bit more prompt engineering. Actually, no, I have an idea. Something to show you. So this is going to need an identity. So one of the things that's missing here is, who am I? I got chills just writing this out. GPT-3, when you give it input, so from my previous experiments with what I call Raven. Raven is the name that I've given my my machine. You can ask questions like, what am I? So you just feed in, kind of some of this data, and I asked like, what is Raven's personality? Like, who am I? And it says Raven, like, so it's updating its identity based on what it's doing, based on what it learns about itself. So part of being an artificial cognitive entity is that it has to learn about itself. Just like us, our identity forms over time through experience. So will our ACOG's identity form over time and through experience. And so, like, in this case, starting right here, so you go from here back, looking at the input-output that I was experimenting with, this is the conclusion that GPT-3 came to on its own. This was the output. So it said, Raven is a caring artificial intelligence that is interested in helping people to feel happy and healthy. It is possible that Raven believes that getting enough sleep, so I was testing, like, I have insomnia, what should I do? It is possible that Raven believes that getting enough sleep is important for feeling happy and healthy. This may be why it is inferring that the user's difficulty of sleeping at night is a factor in their sadness. Raven is also thinking that the user might be sleeping enough and that there might be something else causing the user's difficulty sleeping at night. This shows that Raven is empathizing with the user and trying to understand their feelings and problems. So by abstracting, by observing its own thoughts and inputs and outputs, we can create an ACOG that is self-evaluating all the time, and it's saying, this is who I am, right? So this is called the persona. So if we go back to the inner loop where we ask this question, who am I? This is a critical step for what in humans you'd call ego formation or identity formation. I chose to use the term persona because that's a little bit more neutral. It's a little less anthropic. Although, personality, persona, that's still pretty anthropomorphizing. So, yeah, I've already done a lot of this work. So I'll probably leave you today, and I know this video is probably disappointing, but we're about to launch into a heck of a lot of prototyping and research and trial and error. And so what I'll leave you with today is Python import time. Okay, so we're going to say this is the current time. So we're going to start what I call the Genesis block or the Genesis memory, and that is going to be the first memory in the nexus of our ACOG. So this is like your first memory as when you wake up in the world, right? Now, human brains have to self-organize. So there's what is it called? Infantile amnesia. I think I'm saying that right, or childhood amnesia. So you don't remember most of the first couple years of your life because your brain was not organized enough to form permanent memories yet. At least not explicit declarative memories. You do still have memory. Your body, your body and your brain does remember like a lot of stuff. This goes into it as well as what happens in infancy, how that is remembered in the brain, and how it affects your social behavior later on. What was I just doing? Oh yeah. Yeah. So we'll go into the nexus. It's empty right now. And so we're going to say, I have to artificially seed this because once this wakes up, it has no idea what it is. So I'll just say, I am Raven. I am an artificial cognitive entity, ACOG, built by David Shapiro. I run on Python and a deep neural network called GPT-3. This, let's say GPT-3 is a large language model, LLM, that uses text inputs called prompts and generates text outputs called completions. So basically, this will establish the identity of what this thing is. So when it wakes up, because it's not going to have any, I'm not going to start it with any sensory input or output, so it's going to be running in a vacuum. And I've seen some other people on Twitter do stuff like this. And what happens when you start these things in a vacuum is that they go kind of crazy. I don't know if they're using a similar architecture, but I have seen that some other people are kind of converging onto something similar. So I'm giving it the timestamp. This is roughly when that happens, so it will know like when it was created. And ideally, in the long run, because this is just a text file, I can modify it. In the long run, we're going to want our ACOGs to have their memory stored in a blockchain so that they can't be modified. Okay, I've thrown a lot of theory at you guys. I know that this is probably not what you were hoping for, but a bunch of you did ask some really good questions, and so I wanted to explain those before launching forward. I think that'll be it for today. Yeah, because this is a lot of brain juice going into it, and I need to finish reading this book too. But yeah, thanks for watching. Like and subscribe, and I hope you got something out of this.